All right, let's jump right in. We're going to tackle a really cool question today, one that's at the very heart of artificial intelligence. When an AI is staring at a million, maybe a billion different choices, how on earth does it find the single best one? I mean, really think about it for a second. Every single time you punch an address into your phone or your car's GPS, it solves this absolutely massive puzzle, and it does it in seconds. It's sorting through thousands, maybe millions of possible turns. It's definitely not just guessing. There's a powerful, super elegant strategy at play here, and that's exactly what we're going to break down. Okay, so to really get how an AI thinks, you've got to see the world through its eyes. And here's the key. For an AI, pretty much every problem, whether it's getting you across town or winning a game of chess, looks like a giant invisible maze. Now, there's a fancy name for this maze, of course. It's called state space search. But don't let the name scare you. Just think of it like a massive, complete map of every single possible move or configuration, every state a problem can be in. You know, the starting point of the maze is your problem, and the exit, well, that's the solution you're looking for. Let's make this super simple. You remember those little sliding tile puzzles, the 8 puzzle? Okay, so the way the tiles are mixed up at the start, that's your start state. Now, every single time you slide a tile, you're moving to a new state on this giant map. The AI's whole job is just to figure out the shortest sequence of slides, the most efficient path to get from that messy start state to the final solved picture. So, great, the AI has its map, but what if the lights are out? What if it's trying to navigate this maze completely in the dark? Let's take a look at the most basic way to search, which is, well, it's pretty much exactly like that. This is what we call uninformed search, or maybe more accurately, blind search. And it is exactly what it sounds like. The AI knows all the possible paths, right? It sees the layout of the maze, but it is completely clueless about whether any single path is better than another. It has zero sense of direction. It can't tell if it's getting warmer or colder. All it can do is just search, blindly and systematically. And this blind approach basically comes in 2 flavors. First up, you've got breadth first search, or BFS. Think of BFS as the super cautious, methodical searcher. It explores wide and shallow. It'll check every single option 1 step away before it even thinks about looking at things 2 steps away. The good news? It's guaranteed to find the shortest path. The bad news? It can eat up a ridiculous amount of memory. Then you have the total opposite, depth first search, or DFS. This one's the reckless adventurer. It just picks a path and dives down, deep, 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 until it hits a dead end. Then, and only then, does it backtrack and try another path. It's usually faster to find some solution, but there's no guarantee it's going to be the best one. So, what's the big takeaway here? Yeah, these blind methods will eventually find an answer, but they are wildly inefficient. For a real-world problem like your GPS, with billions upon billions of possible routes, searching blindly would take, well, you'd get to your destination before it did. It's just a colossal waste of time and energy, exploring millions of totally useless paths. So, if searching blind is so bad, how do we search smart? How does an AI do it? Well, it needs a secret weapon. It needs a kind of compass, something that's always pointing in the right direction, toward the goal. It needs the power of a hunch. And that hunch, in the world of AI, has a name. It's called a heuristic. And a heuristic is really just a fancy word for a rule of thumb or an educated guess. It's a clever little trick that helps the AI narrow down its choices and make a smart move without having to check every single possibility. Let's boil it down even more. A heuristic? It's just a smart shortcut. That's it. For our GPS example, this is the magic ingredient. It's what allows the system to completely ignore all those roads leading you away from your destination and focus only on the ones that are generally getting you closer. Okay, so this is represented by something called the heuristic function, written as h of n. All this does is calculate an estimate, and that's the key word, estimate, of how far it is from your current spot, n, to the goal. The absolute perfect example for a GPS is the straight line distance, as the crow flies. Obviously, you can't drive through buildings, so it's not the real driving distance. But as an educated guess, it's fantastic. All right, so we've got these 2 pieces, right? On one side, we have our slow, methodical, but blind search methods. On the other, we have this smart, but sometimes inaccurate heuristic. So, what happens when you combine the best of both? Well, you get the gold standard. You get the smartest way to find a path. And here it is, the A-star algorithm. Seriously, this thing is a legend in computer science. For decades, it has been the absolute go-to, the most celebrated, most effective algorithm for finding the shortest path. Your GPS, your favorite video games, robots in warehouses, they almost all rely on this one brilliant piece of logic. And believe it or not, the entire genius of A-star boils down to this one simple, elegant formula. F of n equals g of n plus h of n. That's it. F of n is just the total estimated goodness of a path, and it's made up of two key parts, something called g of n, and our old friend, the heuristic, h of n. So let's break that down. First up is g of n. This is the easy part. This isn't a guess. This is the actual cost, the exact distance you've already traveled from the very beginning all the way to where you are right now, at point n. It's the journey so far. And the second part, of course, is h of n, our heuristic. This is the estimated cost from where you are now all the way to the finish line. This is our hunch, our educated guess, our smart shortcut to the end.
Okay, let's put it all together. Picture this. You pull up to an intersection. Your GPS is now calculating that f of n score for every single road leading out of that intersection. For each one, it takes the distance you've already driven, that's g of n, and it adds the straight line as the crow flies distance to your destination, that's h of n. Whichever road has the lowest total score, that's the one it tells you to take. And it just does this over and over and over at every single turn, perfectly balancing the known past with an intelligent guess about the future.
Now, here's the really cool part. This is the secret sauce that makes A-star not just fast, but optimal. That means it's guaranteed to find the absolute best, shortest path. But there's one catch. The heuristic has to be admissible. And all that means is that the heuristic has to be an optimist. It can never overestimate the actual cost. Our straight line distance is perfect for this, right? Because a straight line is always the shortest distance between 2 points. So it will never guess a distance that's longer than the actual winding road. And look, this whole idea is so much bigger than just getting you to the grocery store. This fundamental concept, searching a giant maze of possibilities using a smart shortcut, it applies to an absolutely incredible range of problems. I mean, the exact same logic that finds your route on a map can be used to find the perfect sequence of moves to win a game of chess. It can blaze through a Sudoku puzzle. It can figure out the most efficient flight schedules for an entire airline. Or it can guide a little robot through a chaotic warehouse. It is basically a universal problem-solving engine. And that kind of brings us back to us, doesn't it? Because this isn't just about computers. We humans, we use heuristics all the time. You know, that little voice that says, traffic on the main road looks bad, I'll take the side streets. Or that rule you have, I'll do the hardest thing on my to-do list first. Those are your personal heuristics. So it makes you wonder, what are the smart shortcuts, the rules of thumb that you use to navigate the maze of your own daily life?